pleasure to introduce Nitish to talk about building production-ready MCP servers from protocol to patterns. Take it away, Nitish.
Thank you. Hello, everyone. So English is my second language, so if you don't understand anything, it's probably me. Just grab me in the hallway and we'll talk. For me, curiosity is what got me into software, got me into MCP, and possibly got you in this room to understand a bit more about MCP. So if I just want it to be a bit more interactive, if you can raise hand if you have heard of MCP, tried something around it. Wow, pretty much more than half of the room. That's good. What MCP stands for is a protocol for providing context to models, right? It's not backwards. It's actually intentionally that way, that you have a protocol to providing context to the models so that they can answer questions specifically for your use case, and hopefully a bit more intelligently and give you the right thing which you were looking for, right? What we are going to do here is look at how MCP is kind of changing stuff. So I'll give you a very short intro on what is MCP, right? What it's solving. Then we'll dive right into how you can do it with Python. In this case, FastMCP is what is being provided right now, which is a phenomenally good framework overall. And then we'll go into patterns of what I have seen working with some more MCP servers being actually implemented. Lastly, we talk about how to actually get it into distributed systems, standard distributed system stuff, where you can deploy it, whatnot. And last to it is where we talk about how much of the adoption has been. And trust me, this is a very quick changing area. This, if you can see, it's my 12th iteration of the presentation, just based on how many changes are kind of keep coming in. And just about, I think, Friday or something, we had the registry come up for MCP. So you can now have an official place where you can find like MCP servers to use. Okay? All right, so why we kind of went towards standardized protocol? I think it's more standard and end-to-end problem. People were using LLM models for answering questions on their systems. They were designing one-off systems based on calling their own APIs, getting their own knowledge bases created, getting them vectorized or RAG or whatever that choice of tool might be, but essentially getting their knowledge base onto for LLM to use and answer questions with a better context. And that was causing to be a problem of like if you have, let's say, 10 applications using hundreds of enterprise tools to like thousands of integrations happening there. Now, coming with MCP, you might have heard this tagline all across. It's a USB-C for AI. And what it's essentially solving for is giving you standard way of talking to the model and talking back from the model. So a lot many things happen there. It is based on JSON RPC 2.0. So pretty much JSON everyone is familiar with. You can have, I've shown a small snippet of the model here. It's you can provide an ID, you provide a method which you're calling, and you provide the request params, like what essentially that tool call or a resource call is, right? How does that stand in terms of like just the block diagram for us? Everyone might have tried something around like Cloud Desktop or any of those host applications. They use what we call as the client SDK. And the MCP server is where your code resides, maybe talking to your external APIs, maybe talking to your database directly, whatnot. And that communication happens via JSON RPC 2.0, right? What's important to me, essentially, having developed some of them, is looking at what sort of features we have. So tools, which a lot of people have been familiar with, is essentially how you actually start interacting with external APIs. A lot many people have used OpenAPI specs directly or whatnot. Resources, a bit more nuanced. You start looking at direct resource access, getting databases or data from it. Prompts, very standard, like in terms of how you can do customized prompts to make it a bit more helpful in terms of how you query the LLM for actual data. And sampling, I introduced that. Sampling, I put it here as a separate one because that's what's going to help you see that MCP is not just like a one-way communication. It can actually interact back with the LLM, get back a response, and go from there. So if time permits, I'll quickly give you a small snippet on why sampling is important. Like, imagine you asked it a question about saying, here are my 10 tools which I'm using here, maybe to get the user profile, get his or her order information, and compile that and give me like a succinct information on like their timeline on how they have used it. So what an MCP server can do is grab 5 or 7 API calls, get that data, and then go back to the user asking, hey, now can I make an LLM call to summarize this data and finally get it back to you. So if you have seen Claude Desktop doing, hey, I'm researching now, and I want to do like a quick check with you whether it's allowed to call this API or call this web page or not, that's what essentially sampling is, so that it can make a tool, it can make an interactive call back, get summarized data, and then further process it and give it back to you. More succinct, actually like more useful information rather than giving you a spit out of like, okay, here are your 10 API calls which you asked me for. Okay, and Python SDK is already available for MCP, but what's really helpful is pretty much based on FastAPI, what we have here in Python, FastMCP. You can see it's pretty much like 5 to 7 calls where you do FastMCP telling a server declaration to do, decorators to call, like, okay, I want to do an MCP tool, right? Here we are doing a search query, search the database, get me data back. Everything is based on type hints and pydantic validation. So you can actually say like, okay, verify my input parameters, like it's a string, verify my input limit, which is being provided, and this is my output structure, data structure, which I want to use, right? So overall, it has many things built in. We'll also talk about like, okay, there are lifecycle hooks which you can use in terms of patterns, and that makes it a lot more sort of native how you want to develop and customize your own application. Right, let's start with server composition. So if people have had experiences with like multiple enterprise application APIs being developed all across, I think GraphQL made it more sort of like prevalent in terms of like composing graphs into one like big gateway, and then you can start using it. In some ways, server composition is that where you have multiple different teams working on their own MCP server, and then what you can finally do is you have a single composition place where you have your main application being called, where you can do static composition or you can do a dynamic one. What that means is static composition just copies all your tools, resources into that main MCP server, and that's what is essentially now hosted or running. Dynamic one is like you have another one which is running separately, like here a calendar service or a database service, and that is being called when you actually call this main MCP server. So it's offloading the call to another server down the line, which maybe it starts with like, let's say a /db prefix or a /calendar prefix, and then you kind of go from there, right? But the main point of this one is like if you have sub-teams kind of working on different parts of tools, this is where you can compose and have one specific place. I think AWS is doing more of like an elaborate one where they're doing right now an MCP gateway that handles not only just composition, but they also do like authentication, authorization stuff altogether. So make it more granular and kind of go from there. That is an open source repository one. I'll have a link at the end maybe. Right. Talking about schema validation, that's coming as a first-class citizen from FastMCP with Pydantic. What that helps you do is say what I want to validate and always do validates user input, so never trust that. Here is a small snippet which is showing like, okay, a search request comes in, I want to do a sanitization of that query, and that is what is being fed. So I take up the base model, say like, okay, replace sort of a SQL injection related stuff there, and finally send out that query for actual DB search, right? So this is, again, sort of very common example in terms of SQL injection, but you can do a lot more stuff in terms of just validating queries, checking params which are being provided, or like kind of removing something or shipping whatnot. All right. This is a bit more involved. So what we start getting into is now our own custom decorators. It's more for caching. We'll take a step back and talk about why caching is important. So LLMs, especially the thinking ones, are not more like us to just get an API response and use it once you have it. They might make that same call multiple times. So what is really happening is they might make the first call asking for a user, and that might be a tool call. You'll get the response back. And then during the reasoning phase, they might make that tool call again to say like, hey, give me that user again. And then during the validation, they might make that tool call again to get the response back. So for your API that got hammered 3, 4, 5 times per query, instead of that, if it's an expensive query, and especially you're doing a third-party integration to like your existing APIs, it's a lot better if you have that cached data there, and they can just use it to validate, to reason, and whatnot, and multiple queries can kind of go that way. And that helps reduce the traffic quite a lot, especially when it's coming from just like services altogether rather than users making those calls, right? Standard stuff applies here. You need to have consistent caching there, consistent keys to kind of maintain it. You can have different times. You can have as many parameters you want, sort of customize it on your own way. What we're doing essentially is wrapping that to load up the cache key from Redis in this case. And here you can see like, okay, when we are making that get weather tool call, we are adding that cache for 300 5 minutes altogether. Right. The next one is more about streaming. So what we are looking at here is trying to make more like, I wouldn't say pagination, but like essentially having calls with a progress bar. If you would have seen like some of the clients, I think Goose was the one which actually implements some of these patterns now, where you can say like, I want to give you data on rolling basis. And what they will do is they will yield out responses in chunks of like 100, 200, whatever, so that you can kind of start getting responses from your database altogether and not have like one whole big query running for a longer time, right? So this is more for like if you want to have like smaller data sets being shared and then kind of looked at from maybe like analytics perspective where you're trying to create a graph out of that data. Sometimes it works, like what we have done in some of the cases is like use that in an MCP server to say, now I want to use that to do a cumulative NPS score maybe. Like, but that's again, very sort of use case basis. I can show you a real example if you talk to me at the end. We have tried it in one case right now, but again, very specialized case when you need it. Again, this is more of like basic table stakes. You do need to have good error handling. Having named enumerations or like having as good detailed errors helps not just here, but also in terms of your observability stack. So talking about a validation error, talking about like a basic exception, talking about some error in terms of your API calls, timeouts, all of these, if they are well documented, that really helps in terms of like debugging what's really happening within your server there. Right. This is something I have been with our teams kind of experimenting with called tool masking. Let's start with one on the right. So what FastMCP already provides you with is sort of hiding parameters. So if you see MCP tool and it says exclude arguments, user ID and API key, that's what you can do is if you call that process data API, what you essentially see in terms of your parameters is just query param, and the user ID and the API key might be picked up internally or might be picked up from headers or whatnot, right? A bit more sort of next step to it or like an advanced pattern to it is you can have, this is a DSL which we are trying to create where we say like, okay, for your process data, what all we want to expose and what we want to hide, and that can be dynamically loaded. So what we're trying to do is process data is like a generic API, but what we really want to call it struct price, and that is the tool name which will start coming in. The same thing for user ID, API keys, all of those kind of get hidden from the user. You might be calling, let's say, if in an AWS environment, a secrets manager to get an API key or whatnot to happen, right? And then you expose it finally, calling this tool as a stock price tool. You can ask user just for the symbol. and internally, you might be doing, okay, module, it's a price, region, it's US, which we are looking at, and in the input schema, it's more like a Pydantic schema, which you're kind of looking for, right? So the left one is not generically available. This is what we are trying to do, but what you can start with at least is excluding some parameters or maybe some internal parameters if you are integrating an existing API, right? In some cases, you might have pagination. In some cases, you might have like just more user metadata being kind of asked for. All of that can go behind the scenes, maybe just for reporting purposes or whatnot. And then you can use this for like just exposing tools via MCP. All right. Having all gone through this, now let's talk about some production considerations, right? This is really sort of as and when you kind of have more enterprise hardened ready applications, really table stakes that you need this to be there in the system, right? So authentication OAuth 2.1 is now supported. If I would highly encourage looking at AWS Gateway part, which is coming in right now, which provides a bit more granular control over what tools are exposed, what not. But you can do authentication from your MCP servers with OAuth here. API key rotation or rate limiting per client is good to have on these systems to be available. You can actually have rate limiting natively with some of the lifecycle methods being used. Authorization, so two-level permissions, that is something not first-class citizen, but you can start looking at. Audit logging, again, all those things, you need to have that under consideration and nothing new per se for a production system deployment. But having these on the MCP server really helps you kind of get insights on like, okay, what tools calls are being made, was that user authorized to actually make that tool call, or role-based accesses for certain things, right? That at the end saves you, or like where you're calling from the LLM to not expose data which a user shouldn't have seen in the first place, right? Now in terms of also like within also for internal tools, input sanitization is a must. Never trust the client input which is coming in, so that's where the Pydantic validation really comes in handy. There was this recent vulnerability 49596, which I kind of keep referring back to within our team, says like it was fixed in O.14 version, but what really shows us like you can do like sort of remote vulnerability sort of execution on the systems just by some of the older vulnerabilities which were available, because this was run on a STDIO, the standard IO MCP server. But again, please look at from a client doing authentication properly or authorization stuff which is happening both, validation of the inputs, and then execute on the actual MCP server from there on. Right, observability stack. What I see as key metrics helping us is cache hit rates. That's very helpful in terms of when you have like long-running API calls. The token usages which are happening. So this one is very helpful in the cases we talked about tool masking. You might have seen some of the posts about GitHub MCP server and how much context it automatically takes in if you have all those tools already exposed. So that's where the token sort of tool masking really helps, where you want to make it like really specialized servers for smaller, maybe read use cases, write use cases, things like that. Error rates of the tools, what you're seeing, maybe P95, P99 latencies, which you're seeing there. And again, your standard ELK stack might be helpful here. What's really helpful is having like proper logging, a structured logging to it with proper error validations, error enums or whatnot to be used there. Deployment, we have tried Kubernetes clusters to be set up, mostly doing streamable HTTP right now. There is a support for standard IO when you're doing, again, that's the first one which you essentially start with. But highly recommend to start looking at streamable HTTP. It is not a big change to do if you're trying to move to it. With FastMCP especially, you can just say like, okay, streamable. I think it's HTTP streamable, if I'm not wrong. Yeah, transport streamable HTTP, and then you kind of go from there for your server setup. All right, sir. Now, I don't have a actual Wi-Fi connection properly in, but we'll see if I can show you some of those things via MCP inspector, right? So this is a server available on GitHub right now on my account. What I'm doing here is showing you some of those patterns which I've implemented. You see setting up logging here. You see tracking tool calls. You see MCP validation errors, external API errors, rate limiting errors, things like that being set up. And you see an actual tool call where I'm calling weather service, open weather service here. Cache being implemented for 5 minutes on it, validation of inputs happening, right? And this is all in a single file, so you can look at like, okay, how the implementations are going rather than doing it in multiple files, because it gives you like just a quick look at what are some of the patterns which you have implemented. The next thing is also doing custom routes. So when you're deploying this on, let's say, one of the cloud providers, you can have custom routes like /health to see like whether the server is responding or not. This is generally just for checking your system health rather than kind of calling it as like a separate tool. Standard MCP tools setup and exposing them, resources, and prompts, right? So I think I have this running already. So what I'm running this with, this is with, if I show you here. So that's, MCP provides an inspector, which you can run to see what's really happening on your system. And if I go to the inspector, this is how it looks like, right? It's connected to the streamable HTTP endpoint via 3001/MCP. And you'll be able to see resources, prompts, tools, which I have all set up here. And also, like if you start going into sampling or elicitation, you can all kind of go here and see those and see how they're kind of working. So like a health status, I have that as a resource just to show you like what kind of response can come in. Prompts, if you look at search prompt, maybe like a weather prompt, whatever you provide here, can give you like a proper prompt to say like, hey, this is what I want to copy paste and kind of talk about in terms of prompt. Tools, what you can see is like one is more about getting paginated results. I'm asking for Python, it will give me results based on my offset and based on my limit. And if I run this tool, it will start giving me responses, and you can kind of dig deep into like what is kind of being returned back, right? The same thing for get weather. This will make an actual API call and give you a response back. Hopefully it does. Here. This is an actual API call to make, need to have an API key to kind of get there. So, this debugging tool is especially helpful where you can see like, okay, what has been the client doing to actually talk to the MCP server. So you can see I tried to look at ping, I looked at prompts list, I also looked at like tools list and then tool call. So once clicking on this, it gives me the tool list call. And that's a standard like JSON RPC to say like, give me the tools list, this is what it will return, saying, okay, this is my input schema, output schema, the source database is another one, this is what I'm essentially looking for, required parameters option, right? Okay. If you want to run this server, I have this with Docker running with Redis and Prometheus in there. You can try this out, see how kind of the whole thing kind of runs with some of the patterns which listed. Now, coming to how this is changing and how this is becoming more of like a standard by the day is like, you saw November 24 Anthropic release date. Since then, OpenAI, Microsoft, Google, everyone has adopted. The registry was launched just about like last week. It is a very big community. People are kind of looking at it left and right. So if you have any questions, the Discord community is very active. You can ask questions there. You can reach out to people and also look at some of the enterprise adoptions. Like GitHub has been really big on it. Cloudflare also has like serverless setups altogether available. Block or Square has their own MCP client, which is the most full-fledged client. It has all the things in terms of elicitation, sampling, tools, resources implemented there. quick takeaways from this. More again talking about the patterns, server composition. Start taking a look if you want like different teams to collaborate on like one big server with the gateway to be there. Caching is a must in these servers, especially when you have like heavy API calls to happen. Schema validation is a must, where you have like the inputs kind of coming in and, from users within teams or like external, especially. Right, FastMCP reduces the time a lot overall in terms of development, and also kind of provides you good lifecycle methods to hook onto. The documentation is fantastic. Please take a look. And yeah, for anything in terms of like deploying your remote servers, I think follow the basic guidelines which we have on distributed systems. We start adding observability early, look at horizontal scaling with them, and yeah, begin with one integration on the API tools. I think that's all I have from my side. Here are some references, and you can catch me at the end. Thank you.
Thank you so much, Nitish. Here is a small token
Thank
of
you.
PyCon's appreciation, and can we give it up again for Nitish? Just a round of applause.